I'm going to get you started with your one-step inequalities and just give you some reminders about how we solve these types of problems. Our inequalities, we follow the same process as we do solving equations. We just have to maintain our inequality symbol as we work. In the first problem, we have x plus 7. Again, our goal is always to isolate the variable. In this case, it's x. So the very first thing that I'm going to do is subtract 7 from both sides. And I want to show that by writing out my minus 7. And then I'm going to draw my inequality symbol down. And 4 minus 7 is going to leave me with negative 3. So this means that x can take on values that are either negative 3 or greater. So to graph our solution, we want to show all the values that x can take on. And then to check yourself, you can pick any number that is on your solution, your graph solution. Like I'm going to choose the number 1. Is it true that 1 plus 7 is greater than or equal to 4? Well, 1 plus 7 is 8, which definitely is greater than or equal to 4. So I know I shaded the right way. I'm going to just check my endpoint here on my graph is negative 3. If I take negative 3 plus 7, I get 4. Is 4 greater than or equal to 4? It's actually equal to, so that one all checks out. When we have problems like number 2, we have to undo our division. And in order to undo division, we have to multiply on both sides of our equation. And that means that the 3's will cancel out on the left. And I'll actually be left with, and I'm going to move over here, x is less than, I'm maintaining my inequality sign, and 5 times 3 is going to give me 15. So when I go to my number line, I need to leave that open on 15, and values less than. Let me just check. If I go this way, is 6 divided by 3 less than 5? Is 6 divided by 3 is 2, which is less than 5? Absolutely. Let's see, 0 divided by 3. 0 divided by 3 is 0, which is less than 5. Yep. So for sure, this was the right direction. Now look at the strategy I used there, just making sure that I was shading right based on the way that my problem was set up. I'm going to slide down. We undid addition. We undid division. I'm going to go down to number 7. 2x is greater than 4. In order to solve this problem, I'm going to divide both sides of my equation by 2. Divide those out. X is, the mouth is open to the x, greater than 2. Let me check this out. Is 2 times 4 greater than 4? 2 times 4 is 8. Is it greater than 4? It is. Yeah, just checking to make sure that I'm graphing my solution in the right direction. Now, if we go on to the other side of this assignment that you're working on, we're dealing with two-step inequalities. So I'm going to work through number 1 and number 2, and then I'm going to leave you on your own to do the rest. In problem number 1, in order to get x alone, we have to undo the minus 5 that's happening, and we're also going to have to undo the 2 that's multiplied by x. Again, the same kind of idea that we use when we're solving equations. This is going to leave me with 2x, that 5 and minus 5 is 0, is less than, and this is going to be 6. I'm going to move that problem up over here just so I have more room. And to finish, I need to divide by 2. When I divide by 2, I get x is less than 3. So 3 is going to be an open circle because it's strictly less than. And if it's less than, that means I'm going to be shading to the left. Let me just check some values here. Let me use 1. Is 2 times 1 plus 5 less than 11? Well, 2 times 1 is 2, and 2 plus 5 is 7, and that is less than 11. So I'm sure that my symbol and my shading is going in the right direction. In number 2, we have x divided by 3 and then subtract 1 from it. The first thing that we need to undo is the minus 1. I'm going to add 1 to both sides. That's going to leave me with x divided by 3 is greater than or equal to 5. I'm going to again move that problem over here so I have more room. And now I'm in a position where I have to undo division again. I'm going to use multiplication to undo division. And I'm back at, we had an x and related to 15 a minute ago. X is greater than or equal to 5 times 3 is going to give me 15. 15 would be sitting here, and it can be equal to 15. Let's check that. 15 divided by 3 is 5. 5 minus 1 is giving me 4. Is 4 greater than or equal to 4? It's actually equal to it. So I'm thinking I did the right thing here. Cool. Good luck. The rest is yours to finish.